So one of the frequent criticisms LSTM has faced is that there are too many gates, and the complexity of four layers combined with the three different gates is quite complex for somebody to explain why it is really very effective. Then there were proposals that can we simplify it a little bit further, where each cell, instead of a purely three-gate, four-layer model, can we create an alternative model which is simpler? And that is where we got this idea of gated recurrent units, which is probably having fewer number of gates as compared to LSTM. So if you see, the gated recurrence models with GRU has two gates and very few parameters. The two gates are basically, one is the update gate, which determines how much of previous memory to be kept. Then reset gate, which basically talks about how much of the current input to be combined with previous memory. The transformation operations are pretty much similar to what we saw earlier, but only thing is there are much fewer gates here as compared to what we see in the LSTM architecture. So at the start, we look at ZT is nothing but sigma of WZ into ST minus 1 and XT. Similarly, RT is sigma of WR and ST minus 1 and XT. Both are coming from the same two, output of previous state and current input XT. Then we have one gate. What it does is it takes ST minus 1 multiplied with RT and XT and takes the tan hyperbolic of that. Another one is it takes 1 minus ZT of ST minus 1 plus ZT times HT, and ultimately the output HT is a combination of the three-stage operation, unlike a four-stage operation which is performed in LSTM. Again, as I said, the only difference here is, unlike using three gates in LSTM where we had forget gate, input gate, and output gate, here you have represented and refactored the same thing in terms of two gates, which is update gate and reset gate, which are together giving similar functionality as what an LSTM would give. So if you see, comparing the LSTM and GRU, you can see on the left hand side is LSTM and on the right hand side is GRU. So GRU has only three hidden layers. In LSTM we have four hidden layers, and in terms of the complexity, therefore it is less complex as compared to LSTM. But let me tell you, in all our experiments we've done with both LSTMs and GRUs, we have not seen a significant difference in terms of the accuracy levels or the way these are modeled, giving different levels of accuracies. So by default, we tend to use LSTMs as the choice of function. In terms of the equations, you can carry out the same thing what we discussed earlier as the final output HT in terms of XT and HT-1. You see here, there are 6 steps in LSTM, whereas GRU has only 4 steps. But what we've seen is, in general, LSTMs are more accurate and are able to offer more robust long-term memory as compared to a GRU. So unless otherwise specified, we typically model sequential problems using LSTM architectures, and that is considered as the default choice for modeling any sequence problems, whether it is time series sequence or whether it is problems related to predicting text or problems related to predicting sequence of frames in a video, or whatever applications. LSTM is the you can think of as the default architecture which we